Hello, this is the beginning of our fraction unit. First, what we're going to do is we're going to start off with some review. So in this section, the review of lowest terms, mixed, and improper fractions. So lowest terms is when you take a fraction and reduce it to a smaller equivalent. For example, if you have 3 out of 6, you know that that is a half because 3 is exactly half of 6. That is what is called reducing fractions. Okay. In order to reduce a fraction, you need to find a number in common that goes into both the top and bottom. This is why we did the divisibility rules chapter first. Now, you can reduce a fraction several times, all the way until you get to the lowest term. So for example, in this one, we have 36 out of 45. If I'm going to reduce this fraction, 36 out of 45, I need a number that is in common that goes into both of these. Well, right away, I'm going to try 3. If I take 36 divide 3, I'm going to get 12 and 15. Now this is what I mean when I say you can reduce a fraction multiple times. Right away I see 12 and 15 are both divisible by 3 again. Divide 3, and I get 4 out of 5. And that is the fraction reduced all the way. Now, could I have taken 36 out of 45 and divided by 9 right away and get 4/5? Yes. So you can see that there are multiple ways in order to reduce a fraction. Okay. Based on that example, what I would like you to do is pause the video and do these try questions of reducing these fractions. Pause the video now. Okay, so hopefully you reduce these and we're successful at it. I'm going to go through the answers. So I'm going to divide this by 9, divide this by 9, and I'm going to get 2 out of 3. That's my final answer. I'm going to divide this by 8. And I'm going to divide this by 8. And I get 8 out of 9. I'm going to divide 8. Divide 8. Now remember, whatever you divide the top, you must divide the bottom as well. So I'm going to get 1 out of 3. I'm going to divide 14. Divide 14. And I'm going to get 1/2. Divide 7. Divide 7. And I'm going to get 1/3. And that is reducing fractions. As you progress through this unit, every fraction you deal with should be, and you will lose marks if you don't reduce fractions to their lowest terms. Changing a mixed number to an improper fraction is the next thing we are going to talk about. So, a mixed number is any number where there is a whole number in front followed by a fraction. An improper fraction is where the numerator, or the top, is bigger than the denominator, the bottom. So how you're going to do this? First, multiply the denominator and the whole number. So in that case, the denominator is 8, the whole number is 3. So I'm going to go 8 times 3. Add this answer to the numerator. Well, the numerator is 1, so I'm going to add 1. Carry the original denominator over. The original denominator was 8. So 8 times 3 is 24, plus 1 is 25 over 8. Next, it says multiply the denominator, 9, by the whole number, 5. Add the numerator, 2, and carry the original denominator, 9. And I'm going to get 45 plus 2 is 47 over 9. Okay, so based on that, what I would like you to do is pause the video and do these try questions. Pause the video now. Okay, so I'm going to go 8 times 1 plus 1 over 8. And I'm going to get 9 over 8. I'm going to get 5 times 4 plus 1 over 5. And I'm going to get 21 over 5. 3 times 1 plus 2 over 3, and I'm going to get 5 over 3. 16 times 2 plus 3 over 16. 16 times 2 is 32, plus 3 is 35 over 16. Okay. Next, we're going to do the opposite. Change an improper fraction to a mixed number. So, how you would do this. First, divide the numerator by the denominator. So 47 goes into 5 goes into 47 how many times? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Well, 50 is too big, so let's cross that off. And it goes in 1, 2, 3, 4, 5, 6, 7, 8, 9 times. For 45, how many is remaining? Well, from 45 to 47, there's a remainder of 2 over 5. So 9 2/5. How many times does 4 go into 10? Well, it'd be going 4, 8, 12. 12's too big, so it goes in twice with a remainder of 2 over 4. Now, remember what I said about reducing. 2 over 4 is a half. 2 and a half. Okay, 19, 2 into 19. Well, 2 into 19 goes 9 times for 18 with 1 remaining. 3 goes into 25 8 times for 24 with 1 remaining. 8 goes into 9 1 time for 8 with 1 remaining. And those are my answers. Okay. So based on that, what I would like you to do is go through this worksheet, and the answers are all written at the bottom for you to check. Go through this worksheet now. Okay, so you just did this whole worksheet. Let's go over the answers to make sure you understood. So 4 over 2. Well, I'm going to divide by 2, and I'm going to get 2 over 1. This one, I see that 7 goes into both top and bottom, and I'm going to get 3 over 5. This one, I'm going to see that 6 goes into both top and bottom, and I'm going to get 3 out of 4. In this one, I'm going to divide by 3, and I get 4/5. Okay, let's keep going. In these ones, I'm going to divide by 5, and I get 1 over 6. Divide 9, and I get 1 over 3. In this one, sorry guys, did not mean whatever I did there. In this one, I'm going to divide by 7, and I'm going to get 2 out of 7. Divide 8, and I'm going to get 1 out of 4. Okay. Next one, change the following fractions to improper fractions. So, 7 times 2 plus 5 over 7. So that'd be 19 over 7. 16 times 2 plus 1 over 16. That'd be 33 over 16. 8 times 1 plus 5 over 8. Plus 5. So that'd be 13 over 8. 5 times 3 plus 4 over 5. And I'm going to get 19 over 5. 4 times 7 plus 1 over 4. And I'm going to get 29 over 4. 3 times 5 plus 2 over 3. And I'm going to get 15, 16, 17 over 3. 6 times 3 plus 5 over 6, 18. Plus 5 is 23 over 6. 2 times 6 plus 1 over 2. And I'm going to get 13 over 2. Okay, so on the next one, you're going to change each improper fraction to a mixed number. So 16 goes into 25 one time, with 9 remaining out of 16. 4 goes into 35 8 times for 32, with 3 remaining. 3 goes into 7 2 times for 6, with 1 remaining. 8 goes into 21 2 times for 16, with 5 remaining out of 8. 4 divided by 2 is just 2. 7 goes into 12 one time, with a remainder of 5 over 7. 4 goes into 17 4 times for 16, with 1 remaining. 9 goes into 48 5 times for 45, with 3 remaining. Now, this one here can reduce because it's divisible by 3, divisible by 3. So it's 5 and a third if you reduce all the way. Okay. Now, getting started. The number of our campsite is less than 100. It has factors 2, 3, and 5, and it's a multiple of 4. Can you use these clues to find us? How do you know that the campsite number is even? Because 2 is a factor. So because 2 is a factor, it's an even number, so I'm going to cross off every second list, because it's not even numbers. Okay, next, where are the numbers that have 5 as a factor? Well, remember, if 5 is a factor, it either ends in 0 or 5. Well, ends in 0 or 5. 5 is not an even number, so it just has to end in 0. So I'm going to cross off every other list now. So it is only in the final column. All right, so shade the numbers that have both 2 and 5 as factors. Well, that's the final column right here. Circle the shaded numbers that have 3 as a factor. Remember the rules for 3. You have to add all the digits up, and if it's divisible by 3, then 3 goes into it. So 1 plus 0 is 1, 3 doesn't. 2 plus 0 is 2, 3 doesn't. 30 could be it. 4 plus 0 is 4, no. 5 plus 0, 3 does not go into 5. 6 plus 0, yes. Not 70, not 80, 90, and not 100. So now we're down to 3, 30, 60, and 90. It says circle the shaded numbers that have 3, also have 3 as a factor. Done. So we have 30, 60, and 90. How can you tell if a number is a multiple of 4? Well, multiple of 4, remember we would take the tens digit. So let's do 3 times 2 is 6, plus the ones digit, 6. Does 4 go into it? No. So I'm going to cross off 30. Then I'm going to take 6 times 2 is 12, plus 0 is 12. 4 goes into it? Yes. 9 times 2 is 18, plus 0 is 18. 4 does not go into it. So what is Star's campsite number? Her campsite number is site 60. Why? Because it's divisible by 2, divisible by 3, divisible by 5, divisible by 4. Okay. So, what do you think? Decide whether you agree or disagree with each statement. You can decide if 10 is a factor of a whole number without dividing the entire number by 10. That's absolutely true. All you have to do is look at the end, and if it ends in 0, you don't have to divide the whole thing. Every whole number has at least 2 factors. Okay, well, this is not true because 1 is a whole number, and we can go 1 times 1 is 1, and so the only factor is 1. If 2 and 4 are factors of a whole number, then 8 must also be a factor of a whole number. This is true. If 12 is a multiple of a number, then 24 must also be a multiple of a number. Well, this is true because 12 is a multiple of 12, but 24 is not. So that's not true. A factor of two numbers is always a factor of their sum. For example, 2 is a factor of both 4 and 8. So 2 is a factor of 4 plus 8 equals 12. Is this true or not? Well, let's try another example. Let's go 17. Okay, 17 goes into 17, but if I go 1 plus 7, I get 8, but that's not a factor. So there's a counterexample. Okay, so based on that review, hopefully you understood what we're getting into in this chapter.